seats cab and day, he's pretty good there.
I'm Pat Courtney with J-Tech, and today we're going to talk about what a cylindrical roller bearing is. So a cylindrical roller bearing, by its name, cylindrical roller, has basically four components. It's going to have its outer race, or outer ring, an inner ring, or inner race, and then obviously the rollers, the cylindrical rollers, and then some sort of cage. So these cylindrical roller bearings come with different cages. So they can come with a brass cage, or they can come with a steel cage, or some sort of polymer type cage. So why would you use a different cage? Well, in most industrial applications, the most popular industrial application for the standard single row is going to be a pump. And so there's lots of slamming going around inside that pump. So when an industrial pump cavitates, there's this banging noise that's happening, so that there's a slamming occurring inside the pump. So having that brass, which is more malleable and soft, it's not going to fracture. It might get dented a little bit, but it's not going to fracture. Now, if you had a steel cage or a polymer cage, it's more likely going to fracture. So again, for some of the smaller size cylindricals, we're going to use the steel or the polymer cage because they're going to go in lighter, I won't say lighter duty applications, but you're not going to have those high impact loads that are going to be inside there. How big do these get? Well, they go down to about 20 millimeter bore, but then they can go to over 500 millimeter bore. So some of these huge cylindrical roller bearings we're going to be using in steel mills. Several different what we call rib configurations. So what's a rib? Well, a rib is this part that hangs down and captures the roller. And now this particular design that I'm showing here does not have any ribs on the inner ring. So you can see that I can slide this inner ring all the way through the bearing. So we have 5 other designs where we actually put a rib that stops this from going all the way through. What it also does, though, is it allows this bearing to take an axial load. So we can actually push on the bearing from this side and hit this rib on this side. What that rib construction also does, it allows for easier installation. So if I install this onto a shaft, then I can put this in the housing and this will slide right over that design. Now, if I have a rib on there already, that's going to limit me, but it's also going to allow me to have an axial load on the bearing as well. So what are cylindrical roller bearings designed to take? High radial loads. So before we said ball bearings were like medium, cylindricals are designed to take high radial loads and a little bit of axial load, some axial load. Probably light, more in alignment with, let's say, a ball bearing than, let's say, an angular contact. But they have to have that rib construction. These also come in high precision, where they go into CNC machines. These also can go high speed as well. Why are we using the higher precision? Again, it's to control that run out on the shaft. Okay, when the bearing's mounted on the shaft, if I have 2 of these, it's going to control how much the end of that shaft moves. Okay, so that's what the higher precision will do for you, as well as be able to go much faster. So why use a cylindrical roller bearing? So when we look at cylindrical roller bearings in all these different applications, the biggest reason is because they can take a high radial load. A radial load is perpendicular to the shaft. Okay, so it can take, because of the roller design, it's taking that load as a line contact versus point contact. It can take a much higher radial load than, let's say, a deep groove ball bearing. What's interesting about these designs is that you can get a cylindrical roller bearing. This is your cylindrical, this is your deep groove ball bearing. That's exactly the same size. The bore, the OD, and the width of that part are exactly the same. So if I had an application where I was taking too much radial load on a ball bearing, I could replace it with a cylindrical. So a lot of the cylindricals are interchangeable with your deep groove ball designs. That's where this has the biggest impact for your smaller sizes. You're going to see a lot of cylindrical roller bearings that are going to be replacing ball bearing designs because they need a bearing that's going to be able to take that higher radial load. And again, that gets to that line contact versus point contact. The ball can only support so much load because of the amount of surface contact. With that longer roller, you can support it more. Now again, the other, why would you use a cylindrical? Because of that multiple rib design too. So you have different ribs that you can use, different rib options, which again will allow you to assemble the bearing differently. So it gives a design engineer a lot of options on how to assemble that bearing depending on that rib construction. It also gives the design engineer the option to have an axial load on that bearing, as opposed to this bearing, which won't be able to take any axial load. But if you have a different rib design, you can be able to take that axial load as well. Now, what's interesting about cylindrical roller bearings when we compare them to deep groove ball bearings, a lot of times when we think of roller bearings, they can't go as fast as ball bearings. But cylindrical roller bearings can go as fast as ball bearings. So they actually have the same limiting speed. Part of that has to do with just we make this product at a higher precision level, just in the nature of the bearing, just in how we grind the rollers. So it allows us to go that higher speed, but it can go as fast as a ball bearing. So again, when we interchange the cylindrical for a deep groove ball bearing, it can go as fast as that bearing. The thing that is different about this over a deep groove ball bearing is that we can't seal or shield it. And again, it has to do with this inner ring being able to move around, whether or not it has a rib or not. So there's no way for us to put a seal onto this bearing and seal this bearing. So can't be sealed or shielded. Where are cylindrical roller bearings used? Well, the most popular part is electric motors. And why? Because in electric motors, you typically have 2 ball bearings on the shaft. And again, the one end of that shaft is typically going to see more load, the work end of that shaft. So here's your electric motor. The end of that shaft comes out of that electric motor. This work end is going to see higher radial loads than this back bearing. So we keep this back bearing a ball bearing, but a lot of times they'll change this front bearing to be a cylindrical roller bearing because they have more load. So there's some belt pulling on a sheave or a pulley, so it's going to put more load on that side of the bearing, on that side of the motor, so they'll change that to a cylindrical roller bearing. Where else are they used? Gearboxes, CNC applications. So CNC is those machining centers. Those are going to be your high-speed applications. Automobiles, for tractors, bulldozers, those types of transmissions. You're going to have those cylindrical roller bearings in those transmissions. Now, larger CRBs. So when we start getting to big cylindrical roller bearings, as we start to get to really big, those are going to be mostly in steel mills. And why are they in steel mills? Again, because of the tremendous amount of radial capacity that they can take. In a steel mill, what you're doing is you're taking kind of semi-formed steel and you're pushing it in between 2 rolls. You're putting it between these 2 rolls and they're squeezing that steel and sizing it to a certain thickness. So to do that, you have to use tremendous pressure to push down on that steel. And so that load is perfectly radial. It's straight down or straight up, depending on which bearings you're talking about. And so those cylindricals are able to take those huge radial loads, and so these bearings are quite large. So in summary, cylindrical roller bearings, they can take high radial load. They have high radial load capacity. They can also take some axial load depending on the design. They usually replace deep groove ball bearings, especially on the smaller sizes. Available in high precision, so again, they can be used on CNC equipment. And again, they have those multiple rib options, which allows for easier installation, a more flexible design for installing the bearing, and then also being able to take a thrust load as well as a radial load. That brings us to the end of our overview on cylindrical roller bearings. Stay tuned for more bearing training from JTech, formerly known as Koyo.